Hello guys, hope you're doing great. Welcome to my channel, The Consistent Coder. So the problem that we are going to solve today is single number. Let's see what the problem says. Given a non-empty array of integers nums, every element appears twice except for one. Find the single one. You must implement a solution with a linear runtime complexity and use only constant extra space. So we were given an array of numbers where every element is repeated twice except for one number, and we have to return that number. If you look at the example 1, 2 is repeated twice and the number 1 is repeated only once, so we have to return 1. If you look at the example 2, 4 is repeated only once and 1 is repeated twice here and here, and 2 is also repeated twice. So the number which is coming only once here is 4, hence we return 4. So hope you understood the problem. How can we solve this? So the first idea that might come to your mind is hash map. So how can we use hash map? We'll maintain each number itself as a key, and then the value of it will be the count, how many times it is being repeated. For example, for 2, it will be 2 because 2 is repeated twice. The number 1 is repeated only once. Right now we will loop through the hash map and see which of the keys has the value as 1, because that is what we are interested in, and we'll return that key. Similarly for 4 it will be 1, the count, and for the number 1 the count will be 2, and then for the number 2 also the count will be 2, and we'll return the number 4 because the count of it is 1 when we were looping through the hash map. Right, so we can do that, but the problem with that is we are using a hash map, so the space complexity would be O of n, but we need a solution that uses only constant extra space. So how can we do that? We can actually do that with the help of XOR. Let's see what it is. So XOR is basically this. So if you have if you're dealing with two bits, right, so you have something like 0 0, the output will be 0, 1 0, it will be 1, for 0 1 it will be 1, and 1 1 it will be 0. This is the XOR, and if you are more interested in how we got this output, you can actually plug it in here. So for example, let's take this as the A bit and this as the B bit, and if you actually plug these values in this particular formula for the XOR, you will actually get the output as this. So if you're interested in it, you can do it, but I'm not focusing on that. Let's see how we can solve this with help of XOR. Right, let's take an example. For example, I have something like 1 0 and then 1 1. Now I'm XORing with the exact same element 1 0 1 1. Okay, right. Now what is the XOR of 1 1? If you look at the table, it's 0. Basically, if they are the same bits, the output will be 0. Right, so in this case also it will be 0, and for 0 0 also we'll get 0, and then for 1 1 also we'll get 0. Right, so we make an interesting observation here. So if we have a number something like this and we XOR it with the same element, right, with the same number, basically we get the output as 0. Right, now if we try to XOR something, take the number 0 and any random number, say suppose 1 1 0 1, and then if I try to XOR any number, something like this with 0, what will I get? So 0 1, the output will be 1, 0 0 it will be 0, and 0 1 it will be 1, and then 0 1 it will be 1. Look at this, this is same as the number that we have taken, right? So the second observation is that when we XOR any number with 0, we get the same number. So using these two properties, how can we solve this? Let's look at this. If you look at the example 1, if we try to XOR 2 with 2, so we know that if we are XORing the same element with itself, we'll get the output as 0. So from here I got the output 0, and if I XOR 0 with 1, now I'll get 1, which is what I want, right? Because when I XOR with the same element, I'll get the same element. And look at the second example. If I XOR 1 and then I XOR it with 1, I'll get 0. And then if I XOR 0 with 2, I'll get 2. And if I XOR 2 with 2, I'll get 0. And then if I XOR 0 with 4, I'll get 4. Right? So why am I doing this way? Because the order of the numbers is not that way, right? So first I have taken 1, and then I have taken 1, and then 2 2 4. But why didn't I go 4 1 2 1 2? Because it doesn't matter. The XOR is actually commutative in the sense that if you try to XOR 1 XOR 2 is equal to 2 XOR 1, right? So it doesn't matter in which order you are XORing the elements, as long as you are XORing everything, right? So which is why the order of the elements will not matter. At the end, the output will always be the same if you consider the same elements. So I hope you understood what I was trying to say. Let's get to the coding part. So initially, let's have something like the XOR output as 0, because if I XOR anything with 0, I know that whatever it is that I'm XORing with, say for example 2 XOR 0 will give me 2, right? Which is why I'm initializing my output with 0. Now all I have to do is loop through my elements, right? So just loop through it, and then I'll update my XOR output as, so my XOR output would be something like this. Basically what am I doing? I'm taking the current element and I'm XORing with my current output, and then I'm reassigning to my output that I'm actually storing in. So I just simply return this XOR output, and that should do it. So basically I have initialized my output to 0, and then I 0 XOR 2, which is going to be 2, and then 2 XOR 2, which is going to be 0, and then 0 XOR 1, which will be 1, which is what I need. So basically all the elements which are repeated exactly twice will cancel each other out when I'm XORing with, right? Except for one element which is repeated only once. That means that element will stay. Rest of the elements will cancel themselves. Hope you got this, what I'm trying to say. Let's see if this is working. As you can see, this is working fine. Hope you guys liked the video. If you did, give me a like, and I'll be uploading videos related to Blind 75. So if you want to receive updates, please consider subscribing, and have a great day.